If I took one atom of carbon-12, placed it on my super accurate electronic scale and measured its mass, it would be 1.993 times 10 to the negative 23 grams. Now that to me is too hard to comprehend. However, if you do the maths and had 12 grams of carbon-12, we would have 6.022 times 10 to the 23 atoms of carbon. In fact, the value represents the atomic mass in grams. And since all the masses of elements are compared to carbon-12, that means if I had 6.022 times 10 to the 23 atoms of any element on the periodic table, that would give me its mass in grams. Check it. 6.022 times 10 to the 23 atoms of argon is 39.95 grams, just like the periodic table. 6.022 times 10 to the 23 atoms of lead is 207.2 grams, just like the periodic table. Now that number is known as Avogadro's constant, which by definition is the number of atoms contained in exactly 12 grams of carbon-12. A mole by definition refers to the quantity that contains as many elemental units as there are atoms in 12 grams of carbon. Let's look at some correct uses of this word. So the mole. If I had a mole of a good cheese toastie, I would have Avogadro's worth of cheese toasties. That is 6.022 times 10 to the 23 toasties. How much bread would be required to make these cheese toasties? Well, it would be 2 times 6.022 times 10 to the 23 pieces of bread because you need 2 slices per toastie. What about the cheese? Same thing. It would be double Avogadro's constant. Overall, that's a lot of cheese toasties. In fact, if you made that many cheese toasties, you could feed the world's population 6.022 times 10 to the 23 times over if the population was 1 person. So how do we use it? Remembering 1 mole of any element is its relative atomic mass in grams. That is known as the molar mass, as in the mass of whatever you have if you had a mole of it. So what would be the molar mass of oxygen? The relative atomic mass of oxygen is 16, and a mole of it would be 16 grams. No issues there. However, oxygen occurs naturally as a diatomic molecule. There we must multiply it by 2, which gives 32 grams. So 1 mole of oxygen gas is 32 grams, or more commonly expressed as 32 grams per mole. Moving on. When you weigh a chemical sample, you then need to be able to calculate how many moles this contains. We use a simple equation of moles with units mole equals mass, measured in grams, on molar mass, measured in grams per mole, or N equals M on mm. For example, how many moles are there in 5.23 grams of magnesium? Well, we'll write the formula, plug in the numbers, so here's the typical format. Moles of magnesium equals 5.23 grams over 24.31 grams per mole. This equals 0.215 moles. How about the moles of 96.7 grams of water? Let's repeat. Here's the equation. Moles of H2O equals 96.7 grams over the molar mass of water, which is 2 times 1.008 plus 16 equals 5.37 moles. Remembering, with molecules and ionic substances, you have to add all elements within the formula to calculate the molar mass.